प्यारे बच्चों, today we are going to start another topic which is related to Unit 4, Differential Amplifier. And first part of this topic is basic structure and principle of operation. We have two types of differential amplifier here. One is MOSFET based and another is BJT based. So first one is called MOS differential pair and second one is called BJT differential pair. So here we are drawing first one, MOS differential pair. So this is the basic structure. So this is called basic structure. This is the basic structure. This is the basic structure of MOS differential pair. First one. In this differential pair, we use two MOSFETs, similar MOSFETs Q1 and Q2 connected. Source is common, and through drains we have two resistances, RD and here VDD is the supply, and VG1, VG2 are two gate voltages. So this is the basic structure. Now in this basic structure we have two modes of operation. There are two modes of operation. First one is the for common mode input, and second one is the differential model. So we have two modes of operation. So we will discuss today this one, first one. First one, that is common mode operation. First we will draw circuit of common mode operation. Then we will discuss operation, how this operates. So first one is the common mode operation. Common mode operation of MOS differential pair. So again we will use two MOSFETs, Q1 and Q2. Okay, this source is common, and here we have a constant current source supply by zinc battery resistances. At drains we have resistances, two similar resistances, RD and supply BD. In common mode, these two gates are common. So this is the circuit. Two gates are common. So suppose we are using two gates, then this is common, and here we have a supply. Suppose common mode signal applied is VC. This is the common mode signal. So this is the common mode operation. Common mode input operation. This is the current. Now analysis starts for this. So these two transistors Q1 and Q2 are similar. So this is current I, and this current is equally divided. As you know, these currents are equal. Drain and source currents are equal, and gate current is zero. So this is equally divided into two parts. When we apply a common mode input, this current is equally divided in two parts. And now come to voltage. This is the here VGS. This is the VGS. Obviously, this is also same, since these gates are common. Okay. So we can calculate different voltages. Suppose here we have two voltages, VD1 and VD2. Then we can calculate all voltages, terminal voltages and branch currents for this. So first thing is, transistor must operate, or you can say MOSFET here. MOS operates in saturation. And for saturation mode, as you know relation, for saturation, this is the relation, drain current equals half Kn dash this is the relation for saturation, because this drain current is I by 2. Here ID, which is the drain current, is equal to I by 2. So this is equal to half Kn dash 22 upon VOE square. Here, what is this? This is VGS minus VT and called overdrive voltage. Okay. This is the overdrive voltage. So from here we can calculate overdrive voltage also. What is overdrive voltage? So this is cancelled out. You can write this is VOV, this is I divided by Kn dash W upon N under root of this. So this is the overdrive voltage. Now come to the source voltage. Suppose this is the source terminal. Then what is the source voltage? So first thing is overdrive voltage. You know, VOV is given by under root I divided by K dash W upon L. Okay. And what is VS? Calculation for VS. what is value of this voltage, that is source voltage. To calculate this, we can use this VGS equals VG minus VS, and VG is gate voltage is this applied common mode signal VCM minus VS. Therefore, we can calculate VS as VCM minus VS. So this is the VS. This is the overdrive voltage. Okay. So this is the about the VS. Now we can calculate VD1 and VD2. These two voltages are same. VD1 and VD2, these are equal, and you can calculate this VD1 VD2 by applying Ohm's law. So VD, as you know, this is the VDD minus VD1 equals I by 2 into RD. So from here you can write this is the VDD minus I by 2 RD. So these two voltages are same. So what is the differential output? Suppose we take differential output, that is VD1 minus VD. What is this value? This is 0. So differential output for common mode input is 0. So for common mode input, differential output is 0. Okay. So this is the total calculation for the common mode operation. Now we have another part, input common mode range. So next part is the input common mode range. How can we calculate this range? Range means VCM maximum and VCM minimum. We have to calculate these two values. So how can we calculate this? So first we will calculate VCM max. So VCM max is decided by condition that MOSFET operates in saturation mode. And what is condition or saturation? We have two conditions. First is the necessary, that is VGS, gate to source voltage, must be greater than VT, and second one VGD. Second condition is VGD must be less than or equal to. So by using these, we can find maximum value of common mode input. So from here, VGD, this gate to drain voltage must be less than VT, that is VG minus VD. this must be less than Vt. And what is gate voltage? For this we can use gate to source voltage. So Vg, this is the gate. Gate is connected to this VCM. So this is the VCM minus Vd, or VCM equals less than Vd plus Vt. Okay. And what is value of Vd? From here you have calculated Vd, gate voltage, which is equal to same for both drains, Vd1, Vd2, and this is Vdd minus I by 2 into Rd. So you can put this value from here. VCM, this is less than Vdd minus I by 2 Rd plus Vt. Okay. So this is the condition. So from here you can calculate this. Maximum value is given by, so what is the maximum value? Since this is either less than or equal to, so maximum value is equal to this, that is Vt plus Vdd minus I by 2 Rd. So this is the condition for maximum voltage. Maximum voltage is obtained by this condition of saturation. So main thing is that maximum is decided by saturation mode condition. Saturation mode condition is this. This is the common for triode and saturation. This is the minimum required condition. VGS must be greater than or equal to Vt, but VGD is less than Vt for saturation, and VGD is greater than or equal to Vt for triode region operation. So we have two region of operation for MOSFET. Here transistor must operate in saturation mode, and this is the condition. Another condition is minimum value. How can we decide minimum value of common mode signal? So maximum and for minimum for this value. This voltage across this current source is suppose VCS. Let minimum value of voltage across current source is VCS. Means this is the minimum required voltage to operate this current source, and this will decide the minimum value of common mode. So you can write VCM minimum. This is given by VGS plus VGS plus VCS minus VSS, because this is the total drop and this drop must be equal to sum of three drops. One is in between gate and source, so first one is this drop from gate to source, then from here drop across this current source, and then this is the supply voltage. So in this closed loop we have three drops. One drop is from gate to source, then drop across current source, and this is supply voltage. So this is the minimum voltage required. So from here we can calculate this. Okay. You can also write this VGS in terms of overdrive and VT. So what is overdrive? This is the VGS minus VT. So from here you can also write this VCM minimum is equal to VGS equals, what is there, VT plus overdrive plus VCS minus, so you can also write this expression. So this is all about operation of common mode input, how this differential pair, MOSFET differential pair works for common mode input signal. So this is the one part of this MOS differential pair, that is common mode operation. So we have calculated all voltages, currents in drain, currents in source. Okay, obviously gate currents are 0, source currents are equal, I by 2, I by 2, and these currents are also equal, I by 2, I by 2, equally divided. We can calculate VD1, VD2, we can calculate gate voltage, we can calculate this VCM maximum minimum. So all these things are for differential, MOS differential pair common mode input operation. Okay, thank you. In next term we will discuss remaining part.